This is the F-35 Lightning II, the world's most technologically advanced fighter jet, capable of flying at speeds as fast as 1,200 miles per hour, avoiding enemy radar with its stealth design, and even landing vertically. It's arguably the most sophisticated aircraft the world has ever seen. Which got me thinking, what does it actually take to power the world's most advanced fighter jet? And the answer is the world's most advanced fighter jet engine, Pratt & Whitney's F-135. And so when Pratt & Whitney invited me out to tour their F-135 engine facility in Middletown, Connecticut, I of course jumped at the opportunity. Which brings me to today, because I'm taking you inside this incredible facility to learn what goes into the manufacturing of the most advanced fighter jet engine ever built. So here it is, the F-135 jet engine. Over 40,000 pounds of thrust built into this piece of machinery, making it the most powerful operational fighter jet engine in existence. Now we're going to learn all about this jet engine here today, but before we get there, I want to share some interesting history about the facility that I'm standing in. Back in the 1950s, this was a top-secret nuclear propulsion testing center for the US government. It wasn't until 1969, when the government completed their project, that Pratt & Whitney acquired the campus and began doing what they do best, making aircraft engines. And I say aircraft because there's been a lot. For the av geeks out there, this facility has produced engines for the F-15, F-16, C-17, F-22, and of course, the F-35. And it's not just the military. On the civilian side, engines for commercial airliners like the Boeing 707, 747, 777, as well as the Airbus A310, 320, and 330 have all been manufactured right here. But today we're focusing on the F-35, or more specifically, the F-135 engine you see right here. To tell us more about how it works and how it's made, I say we go meet up with the chief engineer, who I'm betting is a lot more knowledgeable about fighter jet engines than I am.
Hey Sam, how you doing?
I'm doing well. I mean, Brent, this place is amazing. Just the scale of it, how many employees you have, what you guys are working on. There's a lot going on.
Yeah, thanks. It's 2 million square feet. We got about 1,200 acres here in the property in Middletown.
You know what I'm saying? No matter where you are, you can wear a suit, but you gotta put on safety glasses. Shit makes zero sense. Nigga got a bald ass head, but you gotta put on safety glasses.
2,400 employees, about 1,400 of production associates, another 1,000 engineers. In addition to assembly floor space, we also have manufacturing space and test cells. Test cells we can test all our military product on.
Well, if it's okay with you, I'd love to do a little walk and talk, because what I'm really interested in is this right here, the F-135 assembly line. How does that process really get started?
Yeah, so we source parts in for the 135 from over a dozen countries worldwide. Poland, Italy, France, just to name a few. The products all come here together in Middletown, where they get kitted and assembled in our final assembly line, which you see in front of you. All right, so this is where it all starts. This is our high pressure compressor assembly, HPC for short. It's really the core of the motor. This is where all the energy begins and goes into the combustor. Now, everything else from here gets built out. So this is after this, we stack it and we move it down the assembly line. This process, though, is especially important. We have to stack these rotors to within half a width of a human hair.
And if you miss that, everything's off?
Everything is off, and you got to go back and restart.
How is that even possible?
Well, a lot of ingenuity, some good machines, and some good people putting them together. So the next stop is core assembly. This is where you can really see the engine start to come together. What's important to know about the 135 is it's assembled into modules. This makes it easier for us to maintain them and upgrade them when need be.
So I heard this engine actually evolved from the F-119 engine, which powers my all-time favorite aircraft, the F-22 Raptor. What lessons did you guys learn from the F-119 that you were then able to take into designing and manufacturing the 135?
That's a great question. We actually learned a lot from the 119, and that's why the 135 is built on that architecture. Because when you think about the maturation of an engine system, it's a very complex machine, and you can learn out a lot of different things over the course of time. So the 135 really stands on the 119's shoulders, but it also delivers best-in-class single-engine safety to the JSF.
Yeah, going from 2 engines to 1, more thrust, more power. It's crazy what this thing can do. Now, at this point in the manufacturing line, the steps vary depending on the specific type of engine being produced. The F-35 comes in 3 different variants: the A model used for air-to-air combat, the C model used for carrier operations, and the B model, which features a pivoting engine nozzle that allows the jet to perform short takeoffs and vertical landings.
This is the Stovall engine. It supports the F-35B model. Stovall short for short takeoff vertical landing. That capability gives our Marines and allies the ability to take off from small airfields or on smaller aircraft carriers than the conventional variant can. It does 50% of its thrust out of the lift fan in Stovall mode and the other 50% out of the swivel nozzle.
So from a visual standpoint, what are the main differences when looking at this thing between the Stovall variant and the conventional variant?
A lot of it is common with the CTOL variant. The main differences are some weight-saving changes, like this OMC duct on the outside, which is organic matrix composites. It's lighter than the metal variant on the CTOL. Also, we have our bypass air offtake. These are for the roll posts that help stability of the aircraft in flight. The biggest difference, however, is our 3-bearing swivel module. So this module can articulate down to 45 degrees in short takeoff mode and 90 degrees in vertical landing. This is the final step in the vertical assembly process. After this, the engine moves horizontal and goes on to final assembly. Quality control and FOD protection is really important throughout the assembly process, but here is really critical to make sure we've done everything right and made sure nothing has gotten in the gas path.
Yeah, so you mentioned FOD, that's super interesting, foreign object debris. I mean, if an engineer's working on this, they drop a pen or anything off their jacket, that could like disrupt the entire engine. So like what protections do you guys have in place?
Pratt & Whitney has an extensive FOD awareness program. So we do training, there's policies and procedures in place, and everybody on the floor maintains a FOD-free workplace. This is another part of our assembly process. It's a smart kit. Effectively, all these parts get kitted and pre-ready for the mechanic. When he finishes his work, he calls for the next kit to come down. Everything's set up in an ergonomic fashion, clearly marked, so we can pull them and put them on the engine in the right configuration. Another interesting part of our assembly floor tools is a smart torque system. These tools help the mechanic precisely torque down all nuts and bolts on the engine to whatever the AFS sheet or build sheet calls out. It's actually one of our best advancements, and it's really helped the quality control of the engine for externals and other parts.
Yeah, can I check that out?
Sure.
It's pretty sweet. So, you know, I see all the engineers here, everyone working. I mean, it's pretty impressive. What does it take to work here at Pratt & Whitney? You know, what are you guys looking for?
Pratt & Whitney is just one business unit in RTX. RTX employs over 180,000 people globally, so there's really something for everybody. But across the board, what we're looking for are smart, motivated, and people who are interested in aerospace.
So one thing I wanted to ask you about is stealth. And for those of you unfamiliar, I'm talking about the F-35's ability to avoid detection on enemy radar. And I'm assuming that stealth is something that had to be considered when designing this engine, right? So what considerations were actually taken?
There's not much I can tell you, but what I can tell you is the F-35 is a 5th generation platform. One of the main differences between a 4th generation platform like an F-16 or an F-15 is its stealth capability. The engine is part of that. So as you can tell, we had the same requirements the aircraft did relative to those capabilities.
And so it was back in, what, 2006 when the first F-135 engine was delivered from Pratt & Whitney. So since then, what improvements to the design and modernization of this assembly line have been made?
Yeah, there's been a lot done both to the floor and to the engine. And when you think about over time, the way we progress a design on the military side, we go from an initial configuration to a final production configuration. A lot of those upgrades go in on a modular basis. As we talk about the future of the 135, that modular configuration is going to allow us to further upgrade the system. So this is the final assembly line for the F-135. This is where all the modules come together and all the final externals are mounted to the engine.
So I see all this setup and tooling. What is all this?
Yes, this is pretty impressive. This engine is actually upside down right now, and these rails allow it to spin 360 degrees. So as the mechanic is installing all the final components and tightening all the bolts, he can do so in an ergonomic fashion.
So once the engine is actually installed in the F-35, is there something that allows it to communicate with the engine, or how does that kind of all come together?
Yeah, it's a great question. So up here is the FADEC. This is full authority digital engine control. So this allows the engine to control itself as well as talk to the aircraft and the aircraft to talk to it. On top of all this, there are thousands of people at Pratt who come together every day to make this engine possible. Mechanics, engineers, supply chain professionals, they're all the reason that we're standing here today in front of this monster machine.
Once the assembly of the engine has been signed off and completed, it then heads over to Building 410, also known as the engine test cell area. Each engine is tested for hours at a time to make sure everything functions properly before sending it out the door to be installed on a real-life F-35. If you've ever seen those crazy videos of engines being strapped down and throttled to full afterburner, this room is where it happens.
Well, welcome to our production test facility. This is where we test the F-135 engine. After the test equipment gets installed, we bring the engine into the test cell using the monorail system overhead, and the operators lock the engine into the thrust bed.
So what's going on here with this big metal cone that, I didn't see that before. What's that about?
Yep, that's a FOD screen, and it's used to prevent any foreign objects from getting ingested into the engine.
So what are you guys testing for in here? What are those things you're looking for?
So we measure airflow, thrust, vibration, some of the temperatures, fuel flow, all of that to compare and certify the engine against the performance specs.
Now what I really want to check out is what's going back there on the business end. It's like this dark abyss. Can we go check that out?
Yeah, that's where all the afterburner gets directed to.
So this is the nozzle of the F-135 engine. I mean, it's huge, but look how far back this goes. I mean, how many feet did you say?
Yeah, the exhaust goes back down more than 50 feet.
50 feet of just exhaust for that afterburner trail, which is crazy. So when you guys are testing, what, are you pushing the throttle up, 40,000 pounds of thrust? What's that like?
Yeah, it's very loud. You can feel it in the control room as well.
Yeah, which is just right back there, and I think that's where we're headed next, right?
That's correct.
Let's check it out.
Crazy.
Welcome to the engine test control room. This is where they're monitoring and observing the actual engine test that happens before it gets shipped out to be installed on a real F-35. And if you come follow me, check this out. This is actually the throttle where they're controlling that thrust and that afterburner that comes out of the engine. And apparently, I'm gonna have a chance to throw this up myself. So let's see what happens.
And this part of the test, what we're going to be doing is we're going to be demonstrating vibe survey and thrust transient. All right? Joe, whenever you're ready, you can go ahead and run it. A vibe survey is a slow axle from idle power to intermediate power. We're gonna stabilize up there for a couple of seconds and then bring the engine back down to ground idle. That's a slow axle, slow decel. And then we're gonna be doing the thrust transient. Rapid axle to 150%, rapid decel to ground idle.
Sounds good, let's hit it. You can really hear that.
You can feel it too.
Nozzle's opening up. Yeah, you can feel it, the rumble. It's rumbling.
All right, Joe, let's bring it back down. During this part of the test, we're monitoring the vibes of the engine, like I mentioned earlier. All right, so we're at ground idle again. The next part, like I mentioned, we're gonna do a thrust transient. That's a rapid axle from 10% all the way to 150%.
So just like a pilot's going full afterburner,
Full
straight up, you guys are
afterburner,
testing that.
full
I
AB
gotcha.
for takeoff. Yep.
All right, let's do it.
Ready, Joe?
Yep.
Hit it.
Need to strap into this one. So 40,000 pounds of thrust right now.
Yep, we're
Just
currently
coming out
over.
the back of the F-135. That's crazy, look at that.
One of them might have any.
Such
blew
a
up
thick
before.
afterburner on this engine. It's like a wide nozzle, it's awesome.
We're very lucky to see this
Yeah.
on every test. All right, let's do a rapid decel.
And just cut it back down, wow.
Just like that, we're back to ground
Responds
idle.
quickly too, that's awesome.
Would you like to try it?
I would, okay.
All right.
Okay, so walk me through this again.
Yep. The engine is at idle right
Okay.
now. All you gotta do is just
Just
clear it.
straightforward.
Yeah. Clear that. Slow. Just go slow and push it all the way up.
Feel like
all
I'm
the
in
way to the stop.
Okay, I feel like I'm in Top Gun. Just, all right, here we go. So we're like Mach 1.6 right now. Just cruising along. That's sick.
All right, you
All right, so if I pull it back down.
Yeah, just pull it back down slowly
and
until you hit the
easy.
stop.
And there we go, idle stop.
Yeah, clear the. Yep,
Clear
there
it
you go.
out.
Yep. All right. So
That's impressive.
We're back at ground idle right now.
Ground idle. So I'm
Yeah.
officially a F-135 or F-35 pilot now.
That
I
was a
guess.
slow axle,
was-
slow decel. Do you want to do it again with a snap?
Yeah, so that's, explain that to me again. It's
Yeah. Just clear the stop.
okay.
Yep.
and
And
straightforward.
Just straightforward. Just like that. During this part of the test, we're measuring the thrust response of the engine against
Gotcha.
the spec.
Gotcha. So everything's performing good right now from y'all's observation?
Everything is in the green. Yep.
Sweet. And Same thing to end it, just straight back, or?
Just pull it all the way back. Yep.
Oh, I mean, that's super cool. Very impressive, incredible engine, and just awesome.
Welcome to the pack line. This is the final step in the F-135 assembly process. After we test it, we bring it here to pack it up, and then we ship it to go on a real-life F-35 jet.
Well, it's honestly pretty cool being in this room, like seeing the engine packed up on a trailer before it goes to F-35. It's like all so neat and orderly. But what I really wanted to ask you about is the future of the F-135. I know there's been a lot of talk in the news about Department of Defense increasing, their asks and demands, modernization. So what is next for this engine?
So what's next is the engine core upgrade. We call it ECU, and really that's an upgrade of the core of the motor, and it's going to enable
What, they're making a flux capacitor or something? Nah, we're seeing how engines are made in aircraft with it. Is low-key, this is low-key fire, but I'm not gonna lie.
more electrical power and cooling. And so as the jet brings on more capabilities, more weapon systems for the warfighter, this upgrade will enable that.
So as the F-35's role continues to evolve, pilots want more. So what does the engine core upgrade program do for them?
So right now, the most important thing for the warfighter is to get what we call Block 4 weapons onto the jet. So there's a technology roadmap and insertion program for the F-35. It's got the most advanced weapon systems coming onto the jet in future years. To enable those weapon systems, we need a core upgrade. We need to provide more electrical power and cooling. And what's most important is that we do that as fast as we can to get those weapon systems enabled to the pilot, and that's what this core upgrade gives them.
And it's more than just the United States, right? I mean, I know a lot of international partners fly the F-35, so will this upgrade go out to them too?
So this is what we call a tri-variant common solution. It means the same F-135 engine, and this engine core upgrade is going to go into the F-35A model, the F-35B, which is the STOVL, short takeoff and vertical landing, and the F-35C, which is the carrier version. It will also go to all the international partners and customers that are part of this program.
Well, everything you and your team are doing here is very impressive, so organized, streamlined, and I guess everything you need when building one of the most advanced fighter jet engines out there. So thanks so much for having me out.
Thank you for coming, Sam. It's been a pleasure to host you.
And to everyone watching, I hope you learned something new. That's it from here at Pratt & Whitney's F-135 engine facility, and I'll catch you next time.